In this session of NC Systems, I'm going to discuss about part programming, where it is related to NC procedure, which I have discussed earlier. NC procedure, where in NC procedure we have 5 different steps need to be followed. Number 1 is process planning. Number 2, part programming. Number 3, tape preparation and tape verification. Finally comes production. Why we do any manufacturing sequences? Finally, the ultimate aim is to manufacture the component. To do this, in NC system, we have to follow up with number of steps, which is a sequential order. Now, for example, if I'll say part programming, today's topic is all about part programming. This is a topic today. Now, while discussing NC procedure, I have explained there are two ways of part programming. One is manual, and number 2 is computer assisted part programming. This is our topic today. What is manual part programming and what is computer assisted part programming? Those two I'll try to explain you in detail today. Now this manual part programming, how manual part programming is performed. The programmer write the machining instructions on a special form. In case of manual part programming, machining instructions are written on a special form which is called a manuscript or part programming manuscript. This you need to remember. What is this part programming manuscript? This manuscript will give you detailing of complete machining process. Listing of this will give you listing of or list of relative tools and workpiece locations. It also give you information about workpiece locations. All right, this manuscript means just by looking at the manuscript, a punch tape can be created which is of 1 inch, which I have drawn while explaining you about. This is how we represent a simple punch tape representation. Okay. In case of NC system, I have explained you all the stuff. So this is how you need to represent the tape. Okay. So the list of relative tools and workpiece locations are there in the manuscript just by looking at that punch tape is prepared. This includes data such as preparatory functions, miscellaneous functions or instructions, speed, feed, and specification. What all the information does this particular manuscript contain? So I said it has a relative tools and workpiece locations. Other than this, you could see this includes number 1, data related to the process. Number 2, data, what type of data? It is not number 2. Now, what type of data? If I say simply data, you may not understand. Then, such as preparatory functions, preparatory commands, let me write it as preparatory commands and miscellaneous instructions. Number 2, this I call it as 1, maybe 2, miscellaneous instructions, information about speed and feed of machining, speed and feed related to that particular machining operations. So the manuscript contains, this particular manuscript contains information, all this information related to that specific operations. All right, now coming back to computer assisted part programming. Don't get confused. Whenever we'll say CAPP in case of CAD system, is also called as computer aided process planning, which is one more topic exists, which is most important topic. But here we are calling it as computer assisted part programming. How does this help writing a program? In CAP, computer assisted part programming, the machining instructions are written in English statements or English like statements. Like the way we write the sentences to communicate with others, in the same way, the instructions are written by using a language called English. The statements are also almost like a simple sentences only. It is not like punch it tape. Okay. That also I try to brief. Next, the machining instructions are written in this form. In case of NC programming language, then these instructions are processed by computer to prepare the complete tape. Finally, these are processed by computer. Why we do processing? Because finally what is required? Computer to prepare the tape. Tape has to be prepared. Tape has to be prepared. The idea is to prepare the tape only. Here by using a manuscript we go, and by using CAPP we go by English like statements which are provided by a computer that will process that. Those instructions are printed on the tape. This computer is automatically punches the tape in the tape format. Now here, whenever I talk about CAPP, two things comes into picture. For example, let me brief you. Two things comes into picture. Number one. Now, for example, what are the responsibilities of a programmer? First one, responsibility of a programmer. Of that is important. Of a programmer. Now his responsibility is to define the part program geometry. What is the shape of the geometry? For example, part, let us say work part geometry. Nothing but he give the complete metric information related to that particular component. Number two is specifying the operation sequence of operations. So he or she who is going to write a program, who is responsible to write a program, they should have an idea about these two. One is the geometry of, or not, no, nothing but the shape of the component or sequential operations or sequence of a tool path. Next, number two, what is the role of a computer is, let me write it as a role here, role of computer. Here we have seen the role of a programmer. Here the role of a computer is, maybe it is input translation. Whatever the information we input, that has to be translated. That is more important. B, bit. Okay. Arithmetic calculation. This is more important. Unless you have this option, then it is not possible to do any calculation part. See, this is the job of again a computer. Then cutter, offset, compensation. Compensation means, what is, now these two are simple terminology. Now when I say cutter, offset, compensation, for example, there is a workpiece where it need to be milled. For example, if I position here is the cutting tool. If I position this, it may come sit something like this here. But the idea is the circumference of the cutting tool should touch the surface of the workpiece. This is more important. It should travel either in this direction or in this direction. That is the idea. Okay. It will rotate accordingly, it will remove the material. That is the idea. So this, from the origin, initial position, I am trying to compensate to the right of the workpiece. Right of the workpiece. That is called the offset compensation. Okay. And finally, D, it is post processor. Now let us see one by one what is input translation. I just try to brief you with simple words. This will convert the coded instructions contained in program into computer usable form. Now input translation, the name itself indicates the code will be decoded. It convert the coded instructions. The coded instructions contained in program into computer usable form. Means the way computer will understand. Computer usable form. This is what it means. Okay, that is how you can elaborate the answer. Now coming to arithmetic calculations, in this particular part programming, the geometry and trigonometry of calculations, whatever the calculations required for that particular geometry, that will be fulfilled by using arithmetic calculations. Cutter offset, as I said just now, offset the tool path from the desired part surface by radius of the cutter. It all depends on the radius of the cutter. For example, again I'll repeat the explanation. Here is the position initially. The diameter is 20 mm. I need to offset to the right, means radius 10 mm has to be offsetted. Let me change the color so that you'll understand better now. If I offset by 10, this is the meaning. Okay, it got offsetted by 10 based on the radius, based upon the radius. That is what it means. Now finally, what is a post process? Okay, this is the final task of a computer in a CAD system, which will give the general instructions and make them specific to a particular machine tool system. Okay. This will make it specific. Means post process is a separate computer program that has been written to prepare the punchy tape for a specific machine tool. Okay. Here the complete work becomes very specific, what to be done, how to be done. So the input to this particular post processor, input to the post process is from again bit A, which is input translation, through input translation only, and arithmetic calculations and cutter offset. So post processor is one where it will get the input from all the three branches. This is how it will follow. Now let me, just for your understanding, other than the explanation, I'll try to draw a simple sketch so that you'll understand. Now let us say I am the user. The idea is to write a program which I call it as APT, Automated Programming Tool. This is a program. Then the idea is to present on CRT. Now in that you have input translation, then arithmetic calculations, then cutter offset compensation, followed by post processor. Okay, let me create a simple block diagram. Alright, this is how I can explain you, and this is one segment, this is the other, and all are interlinked. The information is transferred something like this. Finally, the information is pushed to post processor. Whatever pushed to post processor, that is going to print on a tape. That is going to print on a tape, and that is passed on. Now let me change the color. It is bit not clear. Let us consider this as the tape, and the tape, from the tape it will go to the controller. The tape will roll and read the information, interpret the information, and the same information is passed to the machine tool for operations. This is how, before process I'm explaining you, and this is how the process will be. There will be a user who will use APT program. CRT contains all the information related. This is how the data will transfer and travel throughout the process. Just this simple sketch will make you understand clearly about what exactly this particular NC system is, or CAPP system look like. Alright, this is all for the topic, and if you have any queries or any topic if you want me to explain in detail other than my explanation, you can comment in the box given below. Thank you.